Hi friends, in this video we are going to discuss about different windings. Let's see, actually windings are two types in our electrical machine. Those are closed type of winding and open type of winding. These are especially two types of windings in our electrical system. In generally, this open type of windings are used for AC machines or synchronous machines. In generally AC machines, open type of windings are generally star or delta connected like that. This is simply for AC machine system. But the closed type of windings are used for DC machines. What are those, sir? These closed type of windings are again two types. Your estimation is wrong. Those two types are Gramme type and drum type. These are the two types of windings in closed type. In Gramme type of winding, 50 to 60% of conductor is active. Remaining conductor will not develop the EMF. Only the active length of the conductors is only 50 to 60%. That's why the induced EMF is less. More wastage. That's why we are using drum type of winding in our DC machine. What is drum type of winding? Drum type of winding having around 80 to 90% of active length of conductor. 80 to 90% of active length of conductor. Okay, so in this drum type, we have again two types. Okay, listen silently. This drum type, two types, those are lap winding and wave winding. Are you getting or not? So these are two types in the lap winding and wave winding, which is very well known thing for you people. The DC machine windings are two types. So in this lap winding also, of course, we have simplex lap winding and multiplex lap winding. In this wave winding also, we have two types: simplex wave winding and multiplex wave winding. Like that, we have progressive lap winding, retrogressive, progressive lap winding and retrogressive lap winding, progressive wave winding and retrogressive wave winding. Like that, many windings are there. Right? So whatever, this is generally the windings, different windings of our DC machine. Apart from this, generally here we have a single layer winding and double layer winding. This is also important concept. Sir, what is single layer winding? Single layer winding nothing but one slot contains only one coil side. What is that? One slot will be filled with only one coil side. But in double layer winding, one slot filled with two coil sides. This is a single layer winding and double layer windings. First of all, you have to know what is coil side, and what is turn. Okay, so let's see here. For example, I am drawing a diagram here. See, this is one and this is one. Let's see here. Tell me which of the following is coil, which of the following is turn, which of the following is conductor. You know that here we have a two conductors. Here we have a four conductors. Number of conductors is equals to 2. Number of conductors is equals to 4. Here we have a single turn. Here we have a two turns. Two turns are there. This is also coil and this is also coil. Both are coils. But this coil having only one turn, this coil having two turns. So this is called single turn coil. And this is called double turn coil. Single turn coil and double turn coil. Are you okay? Getting or not? Right? So, in this, every coil having two coil sides. Every coil having must and should two coil sides. Are you getting or not? Right? So, here, one slot filled with one coil side, one slot filled with two coil sides is called single layer winding and double layer winding. So, let's see here, for example, single layer winding. For example, I have like this slots. In these slots, if only one conductor is there, then that is called single layer winding. Nothing but in these slots, we have only one conductor, one coil side, 1, 2, 3, etc. These are the coil sides. For example, if you take a single turn coil, one coil side having only one conductor and second conductor, third conductor, etc. This single layer winding generally used for small AC machines. Are you okay? Getting or not? This is very simple winding. This is generally used for small AC machines. This is not preferable for DC machines actually. Right? So this is about single layer winding. I am removing this one. This is not our topic actually. Now our topic is double layer winding. See, generally the double layer winding, for example, like this we have a 4 slots. Are you okay? In this I have 2 coil sides. In this I have 2 coil sides. In this I have 2 coil sides. And in this I have 2 coil sides. So coil sides per slot. Coil sides per slot is equals to how much? This is represents with U, that is equals to 2. See here, if it is 3, 1, 2, 3, 4, 5, 6, but remember that always the U is a even number. This U must and should a even number. This is a odd number is not possible. Are you getting or not? Yes or no? Right? So this is the even number. Coil size per slot is equals to 2. Next one, let's see what is the last coil side. The last coil side is equals to, tell me what is the formula? N into U. What is N? The number of slots. My slots are 4. What is U? Slots per conductor. 4 to the 8. The last coil side is 8. What is the total number of coils? Let me ask you a question. Actually, this is not last coil. This is also called total number of coils. We can say like that only. Total number of coil sides. How many total number of coil sides? 8. Are you getting or not? Now, I want the first coil side in last slot. This, I want this one. How we can calculate? The first coil side in last slot. What is the last coil side in last slot? The total number of coil sides. That is the number same. But the first coil side in last slot is equals to N into U minus U plus 1. What is the answer, sir? N into U is nothing but 8 minus 2 plus 1, nothing but 7. 7 is the first coil side under last slot. Sir, this is easy, sir. Take another example. Yeah, I will take another example. Let's see here. 1, 2, 3, 4. For example, 1, 2, 3, 4. This is a double layer winding, right? Right. 1, 2, 3, 4, 5, 6, 7, 8. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, can you tell me what is the last slot, last coil side? This is the last slot, last coil side, or total number of coil sides. Last slot, last coil side, or total number of coil sides. Both are same, right? So what is the answer? Total number of coil sides equals to NU. What is N here? N is the 4 again. But what is U here? U, the number of coil sides per slot, 4. 4 4 is a 16. Is very good answer. You can tell this one. But I want the first coil side in last slot. Can you tell me what is answer? First coil side in last slot is 13. How we can get that one? Nu minus U plus 1. What is Nu? 16. Minus U 4 plus 1 is nothing but 13. This is simply the double layer winding. In generally, the double layer windings is used for all DC machines and large rating synchronous machines. We are using double layer winding. What is that? DC machines and large rating AC machines. And generally, the only problem of double layer winding is that crossover problems. Here, crossover problems more comparatively, but generally this is preferable winding in our electrical system. This is simply about the double layer winding importance, right? So now we have to discuss about the lap winding and wave winding, right? Lap winding and wave winding both are very important. We may expect the question from this. So let's see here. Simply this is the lap winding. What is lap winding? See here, the finishing end of one coil connected to starting end of another coil. This is another coil. Its finishing end connected to starting end. And for this coil, this is the finishing. The finishing end connected to starting end of another coil. So lap winding nothing but the finishing end of what is that? The finishing end of one coil connected to starting end of another coil through the what is that? Through the commutator under one pole pair. This is completely what? Lap winding. So lap winding is nothing but the definition. The finishing end of one coil connected to starting end of another coil through the commutator segments under one pole pair. The process will take place under only one pole pair. After that next pole pair. After that next pole pair. I will give you an example question for this lap winding. Just wait. So simply I given you a definition for this. Next one. Let's see here. Here some definitions are there. What are the definitions? First one, pole pitch. You know what is pole pitch? Actually, pole pitch nothing but the distance between two adjacent poles. Of course, but here we can define the pole pitch as a number of conductors per pole or 2 times of the coils per pole for a singleton coil. For singleton coil, one coil having 2 turns, nothing but one coil side having only one conductor. 2 times of coil size, nothing but 2 conductors like that. So here, pole pitch is nothing but Z by P or 2C by P from the coils. First definition. And next definition is back pitch. So, what is back pitch? Can you give me the definition for back pitch? Back pitch nothing but the distance between two coil sides of a coil. The distance between two coil sides of a coil What is that? Distance between two coil sides of a coil from back end or away from commutator. Not at the commutator, away from the commutator. This is the commutator end. This is the back end or away from the commutator. So tell me, what is the definition for back pitch? The distance between two coil sides of a coil. See here, this is my coil, and the distance between the two coil sides of this coil is called back pitch. Sir, this is also coil, right? Is the distance between these two coil sides is also back pitch? Is it correct or not? Yes, this is also correct. Wherever you go in our machine, the distance between two coil sides of a coil from back end is represents with YB, back pitch. And next definition, front pitch. So, can you tell me what is front pitch? Come on, do. What is front pitch? Front pitch nothing but same. The distance between two coil sides of a coil from commutator end. This is called front pitch. Nothing but, see here, this is the coil actually, which are connected to commutator. So from front side, this is actually is called front pitch, and I will give you clarity by taking an example. Don't confuse here. I will give you clarity for this, right? So whatever, front pitch is from commutator side and back pitch is from back end. The distance between two coil sides of a coil which are connected to commutator are from the commutator end. Right, so front pitch and back pitch is there. Now they will ask you a question, what is average pitch? Can you tell me what is average pitch? Average of front pitch and back pitch is the average pitch. Nothing but YB plus YF by 2 is the average pitch. YB plus YF by 2 is exactly equals to pole pitch. That is exactly equals to Z by P. This is fixed. Nothing but the YB plus YF is equals to 2 times of the pole pitch, 2Z by P. You should remember this point now. Right. So pole pitch nothing but Z by P. Back pitch nothing but from the back end, front pitch nothing but from the front end, and average pitch nothing but average of back pitch and front pitch. Here, another concept is there, progressive lap winding and retrogressive lap winding. Generally, the progressive winding is nothing but from here to here. Nothing but from left to right. If the winding procedure is from left to right, that winding is called progressive lap winding. In generally, if they are not mentioned is it is progressive or retrogressive, we should consider it as it is a progressive. If they mentioned like this, then the winding procedure is right to left. But here crossover problems are more. That's why generally we are not considering retrogressive multiplex. Generally we are considering progressive simplex lap windings only. Retrogressive multiplexes are special cases. In generally, if they are not mentioned, we should consider it as it is a progressive simplex lap winding, which is left to right. In generally, in progressive winding, YB is greater than YF. See here, YB is greater than YF. But in retrogressive, YF is greater than YB. Is the one thing. And in progressive, the YB is a positive and YF is a negative. Sir, what is the meaning of this? I will give you an example. And in retrogressive, YF is a positive and YB is a negative. YB is a negative. This is the progressive and retrogressive. So from this, the YB minus YF is equals to plus or minus 2M, where M is equals to 1 for simplex, 2, 3, etc. multiplex. So in generally we are taking YB minus YF is equals to 2 because YB is greater than YF. Whereas in retrogressive, YF minus YB is equals to 2. The difference of these two, back pitch and front pitch, always 2 in lap winding. Here very important thing is that the back pitch and front pitch always odd integers. This is very important. This is not a fraction, sir. Must and should, this is an integer. That too odd integer. Even numbers will not come for back pitch and front pitch. You should remember this point also. When both are add, what is the result here? Even. Yes or no? 9 minus 7, 2. 7 minus 5, 2. 5 minus 3, 2. 23 minus 21, odd number. The resultant is 2, like that. This is the 2. So, whatever I told you already, in general case, the YB minus YF is equals to 2 because progressive winding we are considering. Retrogressive is not considered. Now, let's go for progressive. I already told you YB plus YF is equals to 2Z by P, whereas YB minus YF is equals to 2. So solve these two. When you solve these two gets cancelled. So 2 times of YB is equals to 2Z by P plus 2, where 2 gets cancelled out. So YB is equals to Z by P plus 1. YB is equals to Z by P plus 1. In order to get the odd number, mostly Z by P is a even number. Sir, of course, YB is a odd number. Now I got a clarity. But what is YF? So substitute this YB in this one. Substitute here. What is that? Z by P plus 1 YB minus YF is equals to 2. If you solve this, what is YF? YF is equals to, is it okay? YF is equals to Z by P minus 1. Because even number minus 1 is equals to odd number. I said you YB is greater than YF. And I said you the difference between 2 is equals to 2 if the difference is 2, yes or no. So YB is equals to Z by P plus 1 and YF is equals to Z by P minus 1. Are you getting or not? Yes or no? The average of these two, Z by P plus 1 plus Z by P minus 1. Minus 1 plus 1 cancel. 2Z by P by 2. 2 gets cancelled. Average of these two is equals to Z by P will come. It will come Z by P. This is the back pitch and front pitch. Actually, this is for progressive lap winding. What about retrogressive lap winding? For retrogressive lap winding, YB is equals to Z by P minus 1 and YF is equals to Z by P plus 1. This is for retrogressive lap winding and this is for progressive lap winding. Is it okay? Is it clear? So I just discussed here pole pitch, back pitch, front pitch, average pitch, progressive and retrogressive lap windings. Okay? Right? Next one. YF is equals to Z by P plus or minus 1. Not YF, YB. Take YB. YB is equals to Z by P plus or minus 1. Plus for progressive, minus for retrogressive. And front pitch is equals to Z by P minus or plus 1. Minus for progressive, plus for retrogressive. YB minus YF is equals to 2 for progressive winding and YB plus YF is equals to 2Z by P. These are the different formulas up to now. And next one, winding pitch. What is this? Winding pitch is equals to, winding pitch nothing but the distance between two consecutive top coil sides or two consecutive bottom coil sides. Distance between two consecutive top coil sides or bottom coil sides. This is generally about a winding pitch. Nothing but like this. Two consecutive top coil sides or bottom coil sides like this. This is called winding pitch. I will give you clarity in the example. Right? So, in generally, for our lap winding, the winding pitch is exactly equals to YB minus YF. See, this is YB. YB minus YF is equals to winding pitch. YB minus YF is equals to winding pitch. That's it. Is equals to generally plus or minus 2m, where m is equals to 1 for simplex, 2 for duplex, and 3 for triplex, 4 for quadruple, next multiplex, whatever, and plus for progressive and minus for retrogressive. You know that? Here, plus for progressive, minus for retrogressive. And if these two are odd integers, YB and YF is odd integers, then this is a even integer. This is also important. You should remember the winding pitch is a even integer always. Right? I got it. Next one, commutator pitch. What is this? This is a commutator pitch. Commutator pitch nothing but distance between two commutators. What is this? This is the in terms of commutators. Distance between two commutators in which two ends of one coil connected. This is generally the commutator pitch. See here. For example, this is my one coil. This is one coil. This one coil, two ends are connected to these two commutators. So, commutator pitch is nothing but the distance between these two commutators. The distance between two commutators in which two ends of one coil connected. So, in generally, the commutator pitch is equals to plus or minus 1m for lap winding. This is fixed for lap winding. YC is equals to plus or minus 1m plus for progressive, minus for retrogressive. In general, we can say that the commutator pitch is equals to winding pitch upon 2. If this is 2, 2 by 2 is a 1. It's very simple, right? So, the commutator pitch value is equals to winding pitch by 2. And for lap winding, always YC is an odd integer. No, it may not be odd. It must and should be an integer. Because if the winding pitch is a 4, what is commutator pitch? 4 by 2? 2. It is not odd, right? So, that's why always for lap winding, the commutator pitch is an integer. You should remember this point. And here, very important point is that if the commutator pitch is an integer, then it is called complete winding. If the commutator pitch of the winding is a integer, it is considered as a complete winding. If this is not an integer, then it is considered as a incomplete winding. Here the lap winding is a complete winding, that's why no need of dummy coils. This is a very important point from the lap winding commutator pitch. Always for lap winding, commutator pitch is an integer. That's why this is a complete winding. That's why no need of dummy coils for lap winding. This is simply about the different points in the lap winding. Here another point is there, that is coil span pitch. Coil span pitch is equals to number of slots per pole. What is this? Coil span pitch is exactly equals to number of slots per pole, and back pitch is equals to U times of coil span plus 1. Back pitch is equals to U times of coil span plus 1. We can make that like this. Right? I will explain you everything by taking one example. Is it okay? Right? So note all these points. These are very important actually. Right, sir? So a 4-pole DC generator having 8 slots. What is the given? The number of poles is equals to 4. Number of slots is equals to 8. And 2 conductors per slot. U is equals to conductors per slot is equals to 2, and it is a lap winding. So let's draw the lap winding. Before that, first tell me what is slots per pole. Slots per pole is equals to 2 actually. But what is total number of conductors? The total number of conductors is equals to actually 2 conductors per slot, and totally I have 8 slots. 8 slots and 2 conductors per slot. So the answer is 8 2s are 16. I have 16 conductors here. So let's see here. I have a 4 poles. I have a 4 poles. Is it okay? Clear up to this? Clear? Right. So I said you already, every pole having what is number of conductors per pole, that is called pole pitch. Pole pitch is equals to Z by P, number of conductors per pole, that is equals to 4. Pole pitch is equals to 4. Nothing but the number of conductors are 4 for each pole, like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like this. I have totally 16 conductors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 conductors are there. Clear? Okay. Now, I want the back pitch. What is formula for back pitch? Back pitch is equals to Z by P plus 1. Nothing but 4 plus 1. Nothing but 5. And what is front pitch? Front pitch is nothing but Z by P minus 1. Nothing but 4 minus 1, 3. Front pitch and back pitch. So back pitch is 5. Nothing but 1 plus 5. 1 plus 5 is the 6. And front pitch is 3. I said you that back pitch is a positive and front pitch is a negative. So negative nothing but 6 minus 3. 6 minus 3 is equals to 3. And 3 plus 5. 3 plus 5 is equals to 8. and 8 minus 3 is equals to 5, and 5 plus 5 back pitch, 5 plus 5 10, front pitch 10 minus 3 is 7, 7 plus 5 12, 12 minus 3 9, 9 plus 5 14, 14 minus 3 11, 11 plus 5 16, 16 minus 3 13, 13 plus 5 18. Sir, where is 18? Are you mad? Generally the motor is in round, right? So 18 nothing but 16, 17, 18. 18 nothing but 2. So here for 2 from upside, right? Upside. So this is from second. Sorry, this is not from second. This is from 13th one. 13th to the second. So from the 13th conductor. So now this is minus 3. 2 minus 3. There is no 2 minus 3 actually. This is 18, right? Because 13 plus 5, 18. So 18 minus 3. 18 minus 3 is a 15. So this is for 15. So from the downside, 15. This is from second. Next, 15 plus 5, 20. 20 nothing but 4. Where is my 4? Here is the 4. This is from 15. And next one, 15 minus 3 is the 1. So this is completely what is my lap winding. Is it clear? Everything clear? Yes or no? Right? Right, see here, what is back pitch? Back pitch nothing but the distance between two coil sides of a coil. For example, take this coil. What is the distance between two coil sides? This is one coil side and this is one coil side. This is back pitch. 1, 2, 3, 4, 5. So take another coil. For example, this coil. Of course, from here to here, 1, 2, 3, 4, 5. That is back pitch. What is front pitch? Distance between two coil sides of a coil from front end. For example, take this one. Take this one. So this is a coil. 1, 2, 3. For example, take this one. This is a large, right? It may be 4 or 5. 3 is not possible if you think like that. 1C. So this is the coil. 1, 2, 3. So the front pitch is 3, back pitch is 5. What is front pitch, back pitch, pole pitch? Pole pitch is 1, 2, 3. This is 50% and this is 50% 4. So pole pitch, back pitch, front pitch. Average pitch is the average of them. And winding pitch. What is winding pitch? The top two consecutive coil sides are bottom consecutive coil sides. For example, these are the two consecutive coils on top. So what is the distance between two coils? 1, 2. I said you winding pitch is always 2 or YB minus YF, 5 minus 3, 2. Sir, take a bottom coils. Is it correct or not? For example, these two are the two bottom coils. These are the its coil sides. So 1, 2. Like this. Are you okay? So back pitch, front pitch, winding pitch and commutator pitch. So commutator pitch I already explained there. Of course, let's see. Generally, these all armature coils are connected to commutator. Where is my commutator? For example, this is first commutator segment. This is second commutator segment. Third commutator segment. Fourth commutator segment. Fifth commutator segment. Sixth commutator segment. Seventh commutator segment. Eighth commutator segment. Of course, this is 50% of one and this is 50% of one because these are combinedly. So this is simply number of commutator segments. Are you okay? Right? So like this. See here, this coil is, this is one coil. One coil end is connected here. One coil end is connected here. The distance between these two is called commutator pitch. Commutator pitch is the 1. And this is called winding pitch. Winding pitch is the 2. And where is back pitch? This is called back pitch because 2 coil sides. And where is our front pitch? Generally take this coil. This is the front pitch. So back pitch minus front pitch is equals to winding pitch, or winding plus front pitch is equals to back pitch. Like that we can get all. This is completely what is my lap winding. And now see here, how many number of commutator segments are there? This is my question. The number of commutator segments is equals to number of armature coils. This is important. You should remember this. Here 8 armature coils are there, so 8 commutator segments are there. Number of commutator segments equals to number of armature coils. How many number of brushes are there? How many number of parallel paths are there? So see here, this is one parallel path. 1, 6, 3, 8. This is one parallel path. What is number of parallel paths? Let's see here. How many number of parallel paths are there? Is it okay? Is it clear? See here. So first parallel path is 1, 6, 1, 6, 3, 8. This is the first parallel path. And after this, what is next parallel path? 5, 10, 7, yes or no? 10, 7, 12. This is next parallel path. After 12, what is next one? 9. 9, 14, 11 and 16 is the next parallel path. And what is next parallel path after 16? 13, yes or no? 13, 2 and 15. 15 after 15 is connected to there. Where is there? From 15. This is to the 15. So 15 is nothing but, what is the value? 4. 15 to the 4. 15 to the 4. So these are the 4 parallel paths. So number of parallel paths is equals to 4. Then see here, number of brushes. This is one brush, and this is the second brush, and this is the third brush, and this is having the fourth brush. Generally, when 2 parallel paths are connected, here 2 parallel paths. This is the first parallel path and this is the second parallel path. And this is the second parallel path and this is the third parallel path. And this is the third parallel path. Now this is the fourth parallel path. Like that. So number of parallel paths equals to 4. Number of brushes is equals to 4. Nothing but number of parallel paths equals to number of brushes is equals to number of poles for our lap winding. For simplex, for duplex 2 into pole, for triplex 3 into pole, like that. For simplex, number of parallel paths equals to number of brushes is equals to P. And next one. This is simply about lap winding is completed. Now the special question. In lap winding, one parallel path covers how many poles? I said you in difference. Definition. The finishing end of one coil connected to starting end of another coil through the commutator segment under one pole pair. One pole pair is a definition very important from that. Here see, the first parallel path covers 1, 6, 3, 8. The first parallel path covers first pole and the second pole. Next parallel path covers second pole and the third pole. Next parallel path covers third pole and the fourth pole. Next parallel path covers fourth pole and the first pole. So simply is nothing but every parallel path covers only one pair of poles or 2 poles. Every parallel path covers only 2 poles. Remember this. This is simply about the lap winding. Are you okay? Getting or not? Now this is completed about lap winding. Now, generally, If more number of parallel paths are there, what will happen? Circulating currents increases. What happens, sir? Circulating currents increases due to more number of parallel paths. Okay, we'll discuss about this later. After wave winding, I will discuss about what is circulating currents, how we can avoid them. Right? Very simple winding this one compared to lap winding. See here, this is the wave winding. Wave winding nothing but finishing end of one coil connected to starting end of another coil at or in adjacent poles. This is simply about wave winding. Wave winding nothing but finishing end of one coil connected to starting end of another coil. This is the finishing end of one coil and this is the starting end of another coil in adjacent poles and next adjacent poles and next adjacent poles. For example, this is a coil, this is finishing end and this is starting end. In adjacent poles is called wave winding. So simply this is like a wave and these are commutator segments as usually. And in this case, what is front pitch again? The front pitch nothing but the distance between two coil sides of a coil from front end. And what is back pitch? The distance between two coil sides of a coil from back end. And what is commutator pitch? Commutator pitch nothing but the distance between two commutator segments in which two coil sides of one coil. This is only one coil. It's one coil side connected for this and it's another coil side connected for this. The distance between two commutator segments in which two coil sides of a coil connected. And what is winding pitch? Winding pitch nothing but two consecutive top coil sides are two consecutive bottom coil sides. The distance nothing but two consecutive top coil sides nothing but this one. So this is the winding pitch. Oh, winding pitch. See here, the winding pitch is equals to back pitch plus a front pitch. This is one. So here the point you have to remember that in this case the back pitch is equals to front pitch. Back pitch is equals to front pitch. So that is equals to average pitch. So that is equals to pole pitch. That is equals to 2z by p plus or minus k to get the integer values. So it is equals to 2z by p. The next one, winding pitch is equals to back pitch plus front pitch is also correct answer. Other than that, the back pitch is equals to another formula you have 2c plus or minus 2m by p. Remember this formula for winding pitch is equals to 2c plus or minus 2m by p. If you know the winding pitch, then commutator pitch is equals to winding pitch by 2, nothing but c plus or minus m upon p by 2. This is simply the commutator pitch. So finally winding pitch and commutator pitches are given like this. Based on this, they will ask you question. Already one question is there in competitive exam, very important. So I got front pitch, back pitch, commutator pitch, winding pitch, average pitch, pole pitch and all the values. Of course, another formula I already said you, the back pitch is equals to U of YCS plus 1. Coil span pitch plus 1. Like that also you can find. This is simply about the wave winding. Here, in our wave winding, YC is not an integer. This is not an integer. This is a fraction actually. When this is a fraction, it represents that this is not a complete winding. This is incomplete winding. Wave winding is not at all a complete winding. When it is not complete winding, it may lead to mechanical unbalance during the rotation. To balance that forces, we have to place some coils in the armature. These coils are only used for balancing purpose, not for energy conversion. We are placing the conductors here for balancing purpose, but not for energy conversion. That's why these coils are called dummy coils. Very important thing. Our wave winding is not a complete winding. And here in wave winding we required a dummy coils for balancing purpose. The dummy coils are only coils which are used for balancing of mechanical but not for energy conversion. So here this is not a complete winding, I said you already. The total number of coils is equals to of number of conductors per slot and number of slots. Generally, this is total number of coils. So, active number of coils is equals to P by 2 YC minus R plus M. Minus for progressive, plus for retrogressive, M for simplex 1, duplex 2, like that. This is total number of coils, this is active number of coils. If you want to dummy coils, the total number of coils minus active number of coils gives us the dummy coils. This is simply about the wave winding of our machine. Now tell me how many number of brushes we are using here and how many number of parallel paths are there. Generally, in our wave winding, number of parallel paths is equals to only 2. And number of brushes is also 2. So, number of parallel paths is equals to number of brushes is equals to 2, irrespective of number of poles. Based on that, we can make the answer. So, these are very important. Nothing but in wave winding, number of parallel paths are less. If number of parallel paths are less, the circulating currents are also very less compared to lap winding. Is it okay? And next one, generally in lap winding, number of parallel paths are more. In wave winding, number of parallel paths are less. That's why lap winding used for high current application, wave winding used for low current application. Lap winding used for low voltage application, wave winding used for high voltage application. Lap winding used for high current low voltage application, wave winding used for high voltage low current application. And next one, generally in lap winding, every parallel path covers total number of poles. This is important. Every parallel path covers total number of poles. In that we have two parallel paths, one is the positive, another one is the negative. Two brushes, one is the positive, one is the negative brush. In lap winding, if any one brush damaged, what happens, sir? If any one brush damaged, then total output is 0. If there is no any single brush, then the total output is 0. Clear. And see what I said you here, the lap winding is used for high current low volt, this is used for low current high voltage, and here we have only two brushes and two parallel paths. Each parallel path covers total number of poles. Remember this. Is it okay? Clear? Right. Next one. Generally, if the any one pole strength decreases, one pole strength decreases, nothing but the flux due to this one pole decreases, nothing but the EMF in this, whatever EMF is there, that EMF in these two parallel paths decreases in that pole. We have already only two parallel paths. If any pole strength decreases, in two parallel path voltage decreases, hence the voltage again same. If the voltage is same, there is no circulating currents. That is the reason here circulating currents are less compared to lap winding, because every parallel path covers total number of poles. This is simply about the wave winding of our DC machine. Are you clear? In wave winding, the number of parallel paths, number of brushes are important, and then after winding factor and commutating factor is important. The commutator pitch is not an integer. If it is a integer, then we can avoid dummy coils. Right? Next one thing is there, split coils. So let's see about the split coils. Right? What is a split coil? Here, split coils nothing but, for example, we have a number of slots for this. For example, one coil side placed in one slot. Actually, we have a double layer winding. This is a double layer winding, like this. One coil side conductor placed under one slot and another coil side conductor. For example, my coil side having 4 conductors on each slot, each side. For example, this is my coil, like this. 4 conductors on one side, 4 conductors on another side. So, each coil side having 4 conductors, I have 2 sides. One coil side placed under one slot and another coil side splitted into 2 slots or more than 2 slots. This is placed under only one slot, but this is splitted into 3 slots. This is nothing but split coils. What it is called? Split coils. How this is? For example, take a 2 slots like this, 3 slots. For example, here we have a 2 conductors in one slot and another 2 conductors are like this. This is a double turn coil, for example, like a double turn. Like we have a 2 conductors on one side, another 2 conductors on another side. So here how it is actually it is like this. It is like this. Nothing but here one coil side placed under one slot, remaining coil side, another coil side splitted into 2 slots is nothing but split coil. Sir, what is the problem with this split coil? Due to split coil, the wastage, the active length of the conductor decreases, first one. And the coil sizes are different. See here, this coil size is different and this coil size is different. This is another one. And crossover problem also is there. Another one. Crossover problem, and different coil sizes in a single coil, or different turn sizes in a single coil. And also it may lead to variations in back pitch and front pitch. Yes or no? See here the pitch is different, here the pitch is different because slots increases. Variations in back pitch and front pitch, this is also another thing. So how we can avoid this split coil? This is the question. Can you tell me how we can avoid this? We can avoid this split coil if I said you already one formula, back pitch is equals to U of YCS plus 1, but I want YCS. YCS is equals to, tell me, what is YCS? YB minus 1 by U. If this is equals to integer, then we can avoid split coils. Generally, split coils are less possibility, but if you want to avoid split coils, this YCS should be an integer. This is simply about a small topic as that split coils. Is it okay? Right.